Hey everyone. So I'm going to apologize in advance. My the application that I usually use to record and write and make videos for you is just not working. So what I'm going to do instead is go over the notes that are already uploaded, so the PDF that's already in Student View, and I'm just going to explain kind of what I did in class, and then hopefully that'll make some sense. So I apologize again, but at least this is kind of nice because it'll match up exactly with what's on Student View. So today's lesson was simplifying radical expressions, and so what I want you to think about is what it means to rationalize the denominator of a fraction, and we'll get to that on the bottom of this page here. So at the beginning, our opening exercise was really just to simplify these two radicals as much as possible. So I asked, well, what is the square root of 4 first? And so a lot of people said 2. So what I said here, if I have the square root of 4x to the 4th, I can think of this as two separate radicals, and a lot of times it helps to kind of separate them out. So if I think again about the root of 4, it is 2. If I think about the square root of x to the 4th, I could rewrite this x to the 4th as being x squared squared. So if you think back on algebra and those properties of exponents, something squared times itself will result in x to the 4th. Then I asked, well, what do I see happens when I have a square root of something squared? And a lot of people said, well, the root and the square cancel each other out. So really the square root of x to the 4th becomes just x squared. Another thing to notice here is that my exponent was a 4. It was an even number. If I take that number and divide it by 2, that's what my new exponent is. So when we looked at this, though, we noticed that the square root of 4 is 2, but your algebra teacher probably told you that the square root of a number results in a positive and a negative number, so plus or minus 2. You tend to see that with quadratic formula also. We have x equals negative b plus or minus the square root. So typically you get two answers, and the reason for that, I related over here in the margin, is in algebra you usually get equations that are something like x squared equals 9. To get rid of that square, we take that inverse, or the square root of it, but we'd have to do that to both sides, and then that's where the plus and minus comes in. The reason for the plus and minus is because if I took this positive 3, for example, and plugged it back into my original equation, then positive 3 squared, or positive 3 times itself, would have given me 9. Just like the negative 3. If I would take negative 3, plug it back into my original equation, negative 3 times itself, or squared, would give me a positive 9. And so the plus or minus happens because of the fact that plugging into the original equation, there are two possible answers you can plug into that original equation. In this, though, we notice that this is not an equation. There's no equal sign here. And so when I'm talking about expressions, I'm really just referring to what's called the principal root. And so the principal root means that if I have some positive number in here, so x greater than 0, if I took the square root of it, or the principal root of it, then I'm really referring to the non-negative number that would give me that value x if I squared it. So for example, negative 2 is considered to be a square root of 4 because, again, if I squared this number, I would get 4. But the principal root of 4 is really just 2, the positive 2. So I was telling students in class, just think of the principal root as being the positive root. And that's really all we're working with in today's lesson, is just the positive version. So you will not be doing plus or minus any numbers. Going back to the second part of the opening exercise, I took this 5 to the 10th and I said, well, if I took the square root of that, let's rewrite this so that it's 5 to the 5th squared, which again, if I multiplied those numbers, I would get 10, so properties of exponents. And the reason I did that is because if I take a square root of something squared, those two things are inverses of each other, so they cancel each other out, and I'm left with my answer. Notice my answer is not in a root anymore. It's not in that square root because I already took the square root. Again, if it's easier for you to just think of it as taking that exponent and dividing it by 2, you can totally do that going forward. Just keep in mind that that'll only work for your even numbers. So we'll see some examples in a little bit where that exponent is not even, and then we'll figure out how to handle that. So examples 1 through 4. We said, how do I take a square root of 72? Well, if I type that into the calculator, it's going to give me a decimal. It's an irrational number. I don't want you to use calculators at all for today's lesson. I really want you to just think about your multiplication tables and how you can find perfect square numbers to take square roots of. So for example, if I saw 72 and I said, well, let's split it up to be 8 times 9. So I know the square root of 8 times the square root of 9. If I did multiply those, would give me the square root of 72. The reason I split it up as 8 and 9 is because I know I can take a square root of 9 or a principal root of 9. So the root of 9 is 3, but I can't take a root 8 very easily. So I said, let's split up 8 to be 2 times 4. The reason for that is I can take the root of 4. So I'm going to take the square root of 4 is 2. The principal root of 4 is 2. I'm going to bring down that 3, bring down that root 2. So notice all of these things, I'm still multiplying them all together because originally I was multiplying these together. So all these 4 exercises we're about to do really just revolve around multiplying. Finally, I can't take a root 2 nicely because again, I'll get a bunch of decimals and I don't want that. So 2 times 3 is 6, and then I'm going to bring down that root 2. Typically, you'll write the root after the number that you've got here. So there's that. The next example, now we have a number with a variable next to it. So again, 32, if I did try that, I cannot take a root of it. Try thinking of perfect square numbers. So for example, 4 is a perfect square. 4, 9, what else am I thinking of? 16, 25, 64, right? Think of those numbers. So for example, this one we split up to be 16 times 2. And again, I can take the root of 16. It would give me 4. I cannot take the root of 2. I cannot take the root of x. So now I'm going to recombine those to be 2x in my radical. Bring down the 4. So far, that seemed to be pretty easy, so we go on to the next one, and now we've got fractions, which I know is everybody's favorite. Fractions and radicals. So when I say rationalize denominators, we made a little note to ourselves here to get rid of the radical inside of that denominator. So really get rid of whatever root you have. In geometry, we will primarily deal with square roots. In Algebra 2 next year, you're going to work with cube roots and quartic roots, all kinds of roots, 4th roots, 5th roots, you know. So for now, we'll just deal with square roots. But to rationalize means to get rid of any kind of root that's down here. So it might be a cubed root, it might be a 4th root, anything like that. So first I said, let's take this, and I know typically if this exponent is an even number, I can do what I did in these opening exercises and just divide it by 2. But 7 is not an even number. You could still technically divide this by 2 and get, 3.5, but again, I don't want decimals in this lesson unless the problem gives me decimals to begin with, and in this case, it is not giving me any decimals. So what we did is we kept the numerator the same, so we left it as 5. We split up this x to the 7th to be x to the 6th times x. Both of them are still in radicals. Again, if you want to think of this and rewrite it as something squared, that's what we did over here to the left in the margin. So we said x to the 6th would be the same as saying x cubed squared. The square and the square root canceled, so ultimately we got x to the 3rd as our answer. So really this x to the 6th became x to the 3rd. Again, this is just one extra step, so if you're comfortable with how that works, I would just jump straight from x to the 6th, or the square root of x to the 6th, becoming x cubed. Notice the 5 and the root x stayed the same here. So then next I would try to get rid of that x, or the square root of x in the denominator. So in order to do that, again, we know that if I have something squared, I can take a square root of it very nicely. this is not being squared right now. But I don't want you to think of taking this whole fraction and squaring it, because then you're changing the value of that whole fraction. So if this fraction, say, simplified to the number 4 and you squared it, then it's going to equal 16, and it doesn't equal 4 at all anymore, and that's a problem. So rather than squaring to get rid of roots, what we're going to do is try to figure out another way to get a perfect square in there, and that would be by multiplying it by itself. If I do that to the denominator, though, I have to do it to the numerator, so that I'm technically multiplying by 1 here. So this whole fraction really equals 1, but it's a very special kind of 1 in a way that's going to give me this perfect square number down here. So going on, numerators, if I multiplied 5 times root x, I would get 5 root x. This x cubed stays as the same. Square root of x times square root of x gives me square root of x squared. Again, those will cancel very nicely, just like I want. So now the only thing that changes from this step to the next step is that this square and the square root cancel, so I'm left with just x here. But if I'm multiplying x cubed times x, I would get x to the 4th, and there is my final rationalized answer. So notice rationalized again means that there's no square root down in my denominator. The next one, very similar. So I've got 18 that I cannot take a root of, but if I split it up to be 9 and 2, I can take the root of 9. That would give me this 3. I'm still left with the 2 and the x, so that would, oh actually no, I was left with the 2 and the x. But when we looked at the denominator, again, this is an odd exponent, so I had to split it up so that it was x to the 4th times x, both in radicals. And by doing that, we noticed, oh, I can just cancel out the square root of x because we already determined in this last step that this equals 1. So if this equals 1, I can just cancel it out. This, again, we said became 3, but notice there was a 3 in the denominator, so those will also cancel out. They give me 1. X to the 4th, if I were to divide this exponent in half, there's what I would get. So x squared is the square root of x to the 4th. And this would be my final answer because there is no radical in my denominator. So there we go. Moving on to this next one, it says the triangle shown below has a perimeter of 6.5 root 2 units. So make a conjecture about how this answer was reached. And so looking at these numbers, we recall that a perimeter is just adding up all 3 of those sides. So we added all 3 of these together, and then we noticed the 2, the 3, and the 1.5 is what gives us that 6.5. So before, in these 4 examples, we were multiplying a bunch of things, and when we multiply them, we can combine them into the same radical or split them up, right? So either way, there's a splitting up or combining. Here, though, if I'm adding different radical expressions, then I'm not going to do anything with the root itself. So you notice this is still root 2. So it's almost like saying if I had 2x plus 3x plus 1.5x, I would just have 6.5x. Another way to think of it is this is 2 root 2's, this is 3 root 2's, and this is 1.5 root 2's. How many root 2's do I have total? Well, 2 plus 3 plus 1.5. So you're really just adding all those coefficients. We're going to do a little bit more practice of that on the back. So it says to simplify the expressions as much as possible. If you're unable to do that, then explain why. So again, this one, I have 8.3 root 2's. I have 7.9 root 2's. So total, I have 16.2 root 2's. I just add those 2 coefficients. Over here, we notice that I have root 5 plus root 45. Those are not the same, so I cannot combine those. It would be like saying x plus y. You can't combine those. So in this case, we said, well, what if we try to factor this out and simplify it a little bit? So we split it up to be 9 times 5. We can take the root of 9. That gives us 3. The 5 I can't do anything with, so that stays the same. Now we've got them to be the same radical, so if I have negative 15 root 5's, plus 3 root 5's, I've really got negative 12 of them. This next one, looking at this, we have 11 root 7's minus 6 root 7's plus 3 root 2's. So this is kind of our oddball out. I can't do anything with this guy, so I'm going to bring him down here. but these are both root 7s. So if I have 11 of them minus 6 of them, that means I've got 5 left. So 5 root 7 plus 3 root 2. And I did that example where I compared the root 7s to x's and then the root 2 to a y. So we would know, looking at this, we can only combine x's, we can't combine the y with it. The next one, again, we saw a root 2 and a root 8, so we thought, well, we know we can't combine those, but let's see if we could split it up and simplify. So root 8 became root 4 times root 2. I can take the square root of 4 to become 2. 2 times 2 is 2 squared, or 4, really. And again, now we've got common multiples here, or common radicals. So I've got 4 root 2's plus 9 root 2's leaves me with 23 root 2's. The next one, we noticed 4 plus root 11. We can't really simplify that anymore because the 4 doesn't have a radical with it. The 11 can't be factored out like these ones were because it's prime. So that just kind of stays the way it is. It's already as simplified as it's going to get. The next one, again, root 12, root 75. Those ones are not at all the same, so we thought, what if we split them up and try to simplify? So 12 is the same as saying 4 times 3. Remember, you could split up 12 to be 2 times 6, but the problem with that is you can't take a square root of 2 and you can't take a square root of 6, so that wouldn't have worked out very well for us. So we split it in this way where we've got a perfect square. I can take the square root, which is 2. Same thing here. Somebody was saying, couldn't I split up 75 differently to be like 5 times, I don't know, whatever, I can't think right now. You could split it up that way, but again, you cannot take a perfect root of any of those numbers. So in this case, 3 and 25 works out really nicely for us. The root of 25 is 5. I went ahead and just put it in the front so I could keep this root 3 at the end. So 2 root 3's minus 5 root 3's leaves me with negative 3 root 3's. This one, same thing, split it up, 16 and 2. And then factor that 16, or take the square root of the 16 to be 4. So 4 root 2's plus another root 2 is really 5 of them total. This last one, we split it up to be 13 times 2, but again, I can't take a square root of 13. I can't take a square root of 2. So this actually doesn't help me simplify it at all. Even though they have a common radical, the fact that I can't take this square root very nicely means I can't really combine it with this very nicely. So I would just leave that answer as is. And the last one is another perimeter problem. So if I have these 4 sides, or these 3 sides as a perimeter, we can try to add them up. They're not common radicals, so we'd factor them out. Take whatever square roots we could. So square root of 4 is 2, square root of 25 is 5. We've got a bunch of root 3's left over. So 4 root 3's plus 2 more plus 5 more leaves me with 11. So that's it for this lesson. Please ask each other if you have questions, because there were several people in class. It seems like people in class had a pretty good handle on it. So please ask them questions. Your sub on Monday should be able to answer your questions for this as well. So please ask him for any questions that you might have. And then the answer key for the assignment is up on the whiteboard. So please make sure that you don't take that off of the board in case other people are looking for it. So you're welcome to take pictures with your phone to reference, but don't take them off of the board. That way they don't get lost anywhere. So I will see you guys later on this week. Remember that we've got a test scheduled for Thursday and Friday this week. So you'll be doing your review Tuesday and Wednesday. I will be at school on Tuesday, but I won't be there Wednesday. So anyway, I will see you guys soon. Thanks for watching the video. I hope it made sense. Let me know if you have any questions next time I see you. Bye.